So last Friday we discussed K-maps and how to reduce functions, gate minimization and that sort of thing using K-maps. We're going to continue with K-maps with product of sums simplification. Say you have a 4x4 K-map. And you have a lot of ones. And a few zeros. Now this is a W, X, Y, Z, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. Alright, so here we have, well, let me take out a couple of zeros here. We have a K-map with more ones than zeros. And so we could use fewer groupings, theoretically, with, let's change this to 0. By grouping zeros instead of ones to make it easier, more minimized function. Let's see here, this is W, X, Y, and Z. Okay, you can do the groupings of zeros instead of grouping the ones. So you could have this group of 4 zeros, this group of 2 zeros, and this group of 2 zeros. And then you are creating a complement to the actual function. So the function here would be Z prime, or WZ prime, because it's in Z prime and in W for this group of 4. And W, X, let's see here, no, it's W, X, Y prime. W, X, Y prime for this group of 2 here. This group of 2 here would be W, X prime, Y. Okay, so you have just 3 groupings. Oh, forgot one. Actually, that's I forgot I forgot a 0. Remember what I said before, nobody's perfect. So we'll take that, and we eliminated that group there. So it's x, z, y prime. X, y prime, z. All right, so we have 4 groupings here. Yeah, 4. No, 3 groupings. 1 of 4, wrapping around, and 2 of 2. That's easier than having, let's see here, a group of 4, group of 4, group of 2, and group of 2. So that it's easier to do the zeros than it is to do the ones in this case. Okay? But that gives you the complement of the function, not the actual function. So do a little magic with De Morgan's law. You invert both sides, and then you are given, you work that out with De Morgan's law. You flip the operators and change the primes. So it's F equals W prime plus Z. Okay, you're flipping the Z from Z prime to Z, W to W prime, and the and you're making it a or. You make this or an and then you X prime plus Y plus Z prime. And the last one would be W prime plus X plus Y prime. So you have 3 terms instead of, if you were to have, if you were to use the sum of products, you would have more terms. This should theoretically be more simple. So you can minimize by choosing which to do the groupings with, the ones or the zeros. But it all works out the same. If you're given, like in this situation, let's see here, F equals the sum of 0, 1, 3, 6, 7, 8, 10, 11, 13, 15. How many is that? That's 10 terms. And we learned before that you can go to the product of max terms by finding all the finding the terms that are not here as in the product. So 2, 4, 5, 9, 12. And you can see this is fewer terms. Okay. And then if you so 2 would be 0, 0, 1, 0. So that you'd put a 0 there. 4 would be 0, 1, 0, 0. 5 would be 0, 1, 0, 1. 9 would be 1, 0, 0, 1. And 12 would be 1, 1, 0, 0. Okay. And then you fill in the rest with 1s. Now, this you have some isolated zeros, but still it's only 4 terms. I'm sorry? 14. Okay. 14 would be, oh yeah. 1, 1, 1, 0, right? So have this would be it doesn't add a term to the because you wrap around. So you have, let's start with this one here. That's y prime w or f prime equals w prime x y prime. See how I got that? And then this term here would be w x z prime. It's not x to the power of z, it's z prime. And then you have the isolated two isolated zeros, which is W X prime Y prime Z and W prime X prime Y Z prime. And then do the De Morgan's magic. And there you go. With just 4 terms. Instead of 6, or in this, or up here, 10 terms. You bring it down to 6, which reduces it down to 4 by grouping. As let's see here, how many would it have been if we grouped ones? It would have been 1, 2, 3, 4, 5. It would have been 5 terms with grouping the ones. So which way you go depends on which way is easier to implement in circuitry. What was the so let's see here. That I had something else for you, and I'm trying to remember what it was. I covered don't care conditions before last Friday. Is there any questions about K-maps? Either you doing the sum of products or the products of sums method. Just remember, when you group the zeros, you're doing the complement, and you have to switch it around with the De Morgan's law to get the minimal number of gates. Yeah. These two right here? Okay. W prime, X, Y prime. Yes, you exclude the Z because it doesn't matter whether Z is Z prime or Z. It wouldn't be included in that term. You have to include all four. Yeah, it has to have all four. What about three of you can only group together powers of 2. 1, 2, 4, 8, 16. So you can't group together 3 or 5 together. Just powers of 2. Any other questions about K-maps? I know I went through it kind of quickly between Friday and today. We can probably go through another example. Well, where did I put that? There we go. And we'll start with a sum of products. All right. Let's say 0, 1, 4, 6, 8, 9, 10, 12. Sounds good. We can put that in here and see which one's going to be easier to do, the sum of products or the product of sums. 0, 0, 0, 0. Oh, whoops. That's supposed to be a 1, not a 0. 1, 0, 0, 0, 1. 0, 1, 0, 0. 0, 1, 1, 0. For 6. For 8, it's 1, 0, 0, 0. 9, 1, 0, 0, 0, 1. Or 1, 0, 0, 1. 10, 1, 0, 1, 0. And 12, 1, 1, 0, 0. All right. And then we have zeros filling in here. Now, which one do you think is easier? It's a 50-50. Which one would be easier, grouping the ones or grouping the zeros? Yeah, I'm thinking grouping the zeros as well, because you have 4 groups, and all groups would have at least 2 zeros in it. You see that? Not quite yet. You have this group of 4, this group of 4, this group of 2, and this group of 2. So f prime, what would be the first term of f prime? Let's do the square. What's this one here? No, it's the square here is in both w and w prime, so w would not be in this. xz, yes. Okay, the long group of zeros? yz. And this group of 2? W prime x prime y. Because you're in w prime here, and x prime here, and y right here. And then this group, wxy, yeah. So you have 4 terms. And then do the De Morgan's magic. Here, w goes x plus y prime plus, and w prime plus x prime plus y prime. This coming Wednesday, I will have some more homework for you to practice on. I'm working on putting together some practice problems for you. If it asks for it, yeah. The 3? These 3? No, you can only group powers of 2. 1, 2, 4, 8, etc. And they have to be in a line or a square or a rectangle. So you can't group these 4 together. You can't do this group together. That wouldn't work, or this group together here. It has to be in a rectangle or a line. And yeah, I'm putting together some practice problems for you to work on. Homework, I'll give it out on Wednesday. Have it due probably next Friday. But give you a little practice and all that sort of thing. Where are you guys at in the lab? Proving De Morgan's? Okay. All right, so you haven't gotten to K-maps or anything like that yet. Okay. As long as I'm ahead of the game there, so you you're not going into your lab classes blind. Yeah, that sort of thing. I guess that'll be it for the day. Have a good day. See you on Wednesday.